Good morning, everybody.
Good morning.
I'm glad people showed up. I guess 11:01. I was getting worried nobody would be here today, but I'm glad we have some people coming in. We're going to start today. We're going to do 12.1 again, and we're going to do 12.1 today and tomorrow before we go to 12.2. So we're taking it pretty slow. It will be a short lesson again today, and I'll assign a few questions after today's lesson. So the main thing to talk about today is specific heat. And I mentioned this when we did the s'mores lab. So I don't know if everybody was there for that lab or not. So I'll go through that again today. So this might be review. Specific heat is the amount of energy that must be added to raise the temperature 1 degree Celsius or 1 degree Kelvin.
You said this is 12.1.
Yeah, we're still on 12.1. Specific heat is the amount of energy that must be added to raise the temperature 1 degree Kelvin for 1 kilogram of mass. Now, Kelvin and Celsius are the same degree amount. So you're going to have different degree numbers, but the actual degree marking is the same for Kelvin and for Celsius. So you can use Kelvin or Celsius for that. Another way to think about this would be the amount of energy to raise something 1 degree Celsius or Kelvin, or it's how much or how quickly things rise in temperature. So if we look at a few examples, it'll be clearer. We're looking at water. Its heat capacity. So I'm going to be using them interchangeably. Specific heat is the same as heat capacity. I'll go and write that on here too. I can get this open. There you go. Specific heat is the same thing as heat capacity. They refer to the same thing. So water's heat capacity is 4,180. And the units on here, I'll just write them. It'll be easier than to type that. The units would be joules over kilograms times degrees Celsius or Kelvin. So the book uses Kelvin, so we'll just put in Kelvin, but it can be either. So that's joules over kilograms times Kelvin. Oh, sorry. I'm looking at another example. Let's look at lead. That's 130 joules over kilograms times Kelvin. So you can see that there's a huge difference in heat capacities. Water is about 40 times higher than lead. And what that tells you is that lead is going to rise in temperature a lot faster than water. Water can absorb a lot more energy before rising in temperature than lead can. So if you apply the same amount of heat to water and to lead, lead's going to be a lot hotter than water is. So water is generally the highest heat capacity of anything that we encounter on a daily basis. The only thing higher than water would be ammonia. That's found in Windex. The ammonia would be 4,700. But besides that, water by far is the highest heat capacity. So it's very good at cooling things down, because if it absorbs a lot of energy without raising its temperature, then it's a very good cooling agent. And so we use water to cool down substances because it can absorb energy from that substance without raising its temperature. Looking at another example, glass is in between lead and water. Glass does rise in temperature, but not as fast as metal would. Glass is 670 joules over kilograms times Kelvin. Wood is in between those at 1800. So wood will not raise in temperature as quickly as glass or metal would raise, but it would raise faster than water would raise. Does everybody have these down?
Not yet.
Okay. Also on page 318, there's a chart of some of these and others. So on your homework, you want to refer to that chart. It's on page 318, the very top part. But I just given you a few of many of them that are on that page. Okay, let me go through an example with you on page 318. It says that a 5.1 kilogram cast iron skillet is heated on the stove from 295 Kelvin to 450 Kelvin. How much heat had to be transferred to the iron? So if you ask about heat transfer, we have to use this equation, which I've shown you before. Q equals MCAT. Where Q is the heat, M is the mass, C is the heat capacity, and then delta T would be the change in temperature. Okay, so let's look at what we've been given this problem. We are given the mass. It's 5.1 kilograms. We're given the temperatures before and after. So the initial temperature is 295 Kelvin. Final temperature, 450. And they're asking for heat, which would be Q. So the equation Q equals M, put in 5.1 kilograms times C. Okay, so C is the heat capacity. In this case, we're looking at iron. It's a cast iron skillet that's being heated up. So we have to go to the chart on the top of page 318 and look up iron. And you can see on there it's 450. So C you have to either be given or look it up in the chart. And the units are joules over kilograms times Kelvin. And so C would tell you the units you have to have everything in. You have to have it in kilograms and Kelvin for things to cancel out. So we have kilograms, we also need degrees Kelvin. Delta T is T final minus T initial. So we do 450 minus 295. So just a quick thing about temperatures. You actually can keep it in Celsius. If you've been given Celsius, you don't need to convert it to Kelvin because we're looking at the difference between the two temperatures. If you were to put in Celsius for each of these, 450 Kelvin is 177 degrees Celsius. 25 Kelvin is 72 degrees Celsius. If you were to subtract these two, you would get 155, which would be the same as up here. In both cases, it'd be 155. So a degree Kelvin is the same difference as a degree Celsius. And because we're subtracting the two, we can use Kelvin or Celsius. So even though it says Kelvin for our unit right here, we can keep it in Celsius if we've been given Celsius. Now, in this case, we've been given Kelvin, so let's keep it in Kelvin. But if you've been given Celsius, you don't need to convert it for this equation. Okay, so at this point, we can just multiply this out. and we'll get the answer for energy. So kilograms will cancel out, Kelvin will cancel out, and we would get 360,000 joules. Of energy, so that's what Q equals. For here, we have 3 sig figs. This one is reported to just 2. So our answer would have to have 2 sig figs. So we can keep it like this. This gives us 2 sig figs. Or we could write it in scientific notation where we do 3.6 times 10 to the 5th. Either one would be fine. Any questions about that? Okay, so today, work on page 319. Just do questions 3 and 4 for today. So questions 3 and 4, page 319. And for question 4, this one, you should know that 1 cubic centimeter is equal to 1 milliliter. You have to use that conversion for part B of number 4.
Miss Holly,
Yes,
did you hear about school ending early?
I did. Yeah, that's really sad. Oh, do you mean like not coming back, or do you mean not having an extra week of school?
Not having like the extra week, like Miss Mappy sent.
Yeah, okay, I wasn't sure if you knew about that or not yet. Yeah, so that's right. So May 4th through 8th is a review week. And then final exams would be May 10th through 15th, yeah. And the book return would be May 17th.
Did they tell the teachers for sure that it has to be like a full week of review?
Yeah, Mr. Esther emailed us all yesterday or the day before, and that's what he said. He said May 4th through 8th is a review.
Okay.
So he was pretty clear about that. Is there a teacher who's not following that?
No, not yet. I just was curious on if people were gonna like assign a lot more work on the last week to cram in before.
Yeah, we were told that next week is the last week of class, and that May 4th through 8th is review week. And that's all we can do is just review for the finals starting on the 10th. Yeah, so, and it was pretty straightforward in the email, so I don't think it's gonna be any kind of, misunderstanding, or I can't imagine anybody doing anything else besides what they're supposed to, but definitely if anybody does that, you can let the teacher know that that's what we've been told.
That's really crazy. So when was school supposed to end if everything went fine?
May 20 something. It's the following week. Let me
Okay.
see. I think so.
It looks like 2 weeks or
Yeah, so basically what we're doing is we're ending a week early, so we would have finals week 18th through 20th normally, but for this time we're gonna have finals week 11th through 15th. So everything has just been pushed back a week earlier.
okay.
And we
Thank
can
you,
take
Miss Holly.
on our own time.
Yes,
Right.
You would have from May 10th or May 15th, you would have any time you can take the finals. So we're told as teachers to give everybody their final exam the evening of May 10th. So Sunday night, you should have your final exam for every teacher, and you have that whole week to take your exam anytime.
That's really nice.
Are the exams going to be the same length, or are they going to be shorter?
It's up to the teacher. We're told to have them, pretty straightforward and not incredibly long or complicated. So everybody can do their own exam from teacher to teacher, but most everybody I think is going to just make it, a little bit shorter and not as complex as you'd have in a normal school setting.
Miss Holly, for your study guide, can you post all the equations somewhere that we can use?
Do that. Yeah, you can also use a note card too if you want, like you've been doing throughout the year, but I can also give you all the equations as well.
Yeah, thank you.
You're welcome.
When do you think social distancing will be lifted?
It's hard to know. I mean, nobody knows. I mean, you could ask any expert and nobody could really tell you for sure what's going to happen. I mean, I'm pretty hopeful in the summertime that things will get somewhat back to normal, but I mean, there's really no way to know for sure. But there is a lot of hopeful signs. You know, this curve has been flattened. Cases are not really rising as much as they thought they might. There aren't as many deaths as they thought there would be. So there is a lot of good news. There's a lot of hope. But yeah, nobody can really say for sure what's going to happen in the next month or two, and when things go back to normal. We really don't know. I know that a lot of governors really want to have things open, especially Governor Abbott. He really wants to get things back to normal as soon as possible. So I know whenever he can, things will get back to normal. But when that actually happens, nobody can really say for sure. But I hope it's soon. I mean, I know, it's hard to balance because you don't want to have, an outbreak. You don't, because that would just be awful to just go back to square one and have a terrible outbreak. So you want to make sure that you don't have that, but you want to also balance that with other things, which it's not healthy to be inside all the time. And so it's definitely a balancing act, and there's really no easy answer, and nobody really knows for sure what the best answer is for right now.
Wait, Miss Holly, could you help work through number 4?
Yes. Which part for number 4?
B.
For B, okay. So for B, it's not really clear, but it's going to be 20 liters for the volume of the tank again. So you're using the same volume you did for part A. So we know that the volume is 20 liters. Now we're given in the problem the density of methanol, which is 0.8 grams per cubic centimeter. So what we would need to do is use the volume and use the density to get mass. Density equals mass divided by volume. We know the density is 0.8, that goes in for D. The volume would go down here. But we would also need to convert the units because this is in centimeters cubed, and we need to have them correspond liters to centimeters cubed. So what you should do first is to convert 20 liters to cubic centimeters and then go from there. So we know that there's 1 milliliter equals 1 cubic centimeter. So go from liters to milliliters and then milliliters to cubic centimeters. So 20 liters times, there's 1,000 milliliters in a liter. So 20 times 1,000, and then convert, there's 1 cubic centimeter for 1 milliliter. So it's just a 1-to-1 conversion. So we get 20,000 cubic centimeters for the volume. So that would go in for V now. Okay, so now what we'd have would be density equals mass over volume. Density is 0.8 grams per cubic centimeter. We're trying to find the mass. The volume is 20,000 cubic centimeters. And then we'd solve for M. So we do 20,000 times 0.8. Get 16,000 grams for M.
Does that have to be in kilograms or can we leave it in
Yeah,
grams?
good, exactly. So it should be in kilograms, yes. So we should convert that to kilograms. Okay, so we get 16 kilograms for the mass of methanol. And now we know the mass. The heat capacity we can look up on the chart. It's 2450. And then Q is 836.0. And we can just solve for delta T at that point. Oh, one last thing. I didn't even realize this, but this in kilojoules, and you want it to be in joules because the heat capacity unit is in joules. So this should be converted to joules. We'll go ahead and just do that right now. So there are 1,000 joules in 1 kilojoule. Okay, so now we have Q equals MCAT. We have 836,000 joules for Q. M we found to be 16 kilograms. C for methanol, if you look on page 318, it's 2450. And then we solve for delta T.